And yeah, so, right, I mean, you always need one of these things because unforeseen accidents can happen, cosmic rays can strike, that's our, that's our usual excuse for a totally unexplainable failure. And, ultimately, right, software still has bugs. And so bad things can happen to a disk structure, and you need a mechanism for assurance that the disk structure is okay. And so that's what Analyze Disk does. It works through the entire file structure. Primarily, well, it starts out, it reads the index file, which is where all of the file headers are. And it builds its own copies of the allocation maps, and checks as it's working its way through the index file. To make sure that everything's consistent, so that, for example, it gets to a particular file header, right, and it started with the allocation map marked all free, then it gets to a file header and it looks at the the extent map in the file header and says, oh, okay, well, this file occupies these blocks, and it checks the storage map to make sure that, yeah, that's right now they're free, right, and then it marks them in use, and that way, if you get to another file that also claims those same blocks, it can report that. And then once it's gone through the file headers, then it also works through the entire directory tree, comparing each directory entry to the file header that it points to make sure that the names are consistent, and it also tracks which files actually have directory entries pointing to them, and so that, so we can identify so-called lost files. Those get entered into a special directory so you can find them and deal with them. It also reports the opposite, where it finds a directory entry that's pointing to nothing. There's no file there. And then these things can get cleaned up. So basically, it's building a large database in memory that corresponds to the various pieces of the file structure and make sure that everything is consistent. Now, the important thing to recognize is, all this thing is doing is it's checking the file structure. It's not checking file contents, and we don't really have any way of tracking that. The only way that you're going to discover bad file contents is when an application sees something that it doesn't understand or doesn't make sense, and it gets upset. Again, the file system puts checksums on metadata. So, for example, every file header has a checksum in it, and that's just kind of a nice belt and suspenders check. It doesn't normally catch things. It's been a long time since we've seen anything that would cause a file checksum error, because at this point we can fairly reliably assume that disk storage is perfect. Disk technology has made a lot of progress. I remember back when I started with digital, we used to occasionally get reports of disk controllers just picking bits on disk blocks, and honest to God, like making single bit errors and stuff like that. That is, at this point, totally unheard of. It doesn't happen. Every disk block has 256 bits or more of error correcting and error detection code. So the controllers have actually gotten to the point where, if there are a couple of bits in error as recorded on the disk, they can fix that from the error detection and the error correction codes. And it's only when you get a larger error burst are they even going to report an error back, and even those are just, at this point, very, very rare.